Hello students, welcome back to my YouTube channel Chem Tutor. If you like my videos, then do like, share and comment in my videos and subscribe to my channel. In this video, we will learn about half-life period of zero and first order reaction. For that, we should know what is half-life period. Half-life period of a reaction is the time taken by the reactant. It is the time taken by the reactant to decrease to half of its initial concentration. Okay, here initial concentration means concentration of reactant before reactant at time t is equal to 0, or we can say when the reaction has not started. When the reaction has not started. Okay, now let's understand half-life, how to calculate half-life period for zero and first order reaction. Okay, let's start. Here first we will derive the half-life period for zero order reaction. Okay, for zero order reaction. As per chemical kinetics, the equation for zero order reaction is X is equal to KT. Okay, K is the rate constant. T is the time taken. X is the amount of reactant. Reacted. Okay. So for half-life period, we had known that half-life is the time taken by the reactant to decrease to half of its initial concentration. So in this case, T will be T half. Okay. Since we are calculating half-life period, we are denoting it as T half. Since T half is the amount of time taken to decrease to half of its initial concentration, so X will be A by 2. Because in the previous examples, we had known that concentration of reactions like A gives rise to B, the initial concentration of A was A and B was 0. After some time it was A minus X and concentration of B was X. Okay, so here the initial concentration of A, capital A, is small a. Since half-life is the time taken by the reactant to decrease to half of its initial concentration, so X will be A by 2. This is the half of the initial concentration. Now putting these two value here, we will get that A by 2, we are putting A by 2 in place of X. Next K will be remain as it is, T half. Okay, so T half for zero order reaction will be A by, this K will go here, 2K. Okay, this is the equation of half-life period for zero order reaction. Understand? Now we will calculate half-life period for first order reaction. So let's start. Here we will calculate half-life period for first order reaction. Okay, so earlier we had discovered that the equation for first order reaction is KT is equal to ln A by A minus X. Okay, here A is initial concentration. Okay, A minus X is concentration after time t or at the time of observation. Similarly, in this case also, since we are calculating half-life period, we will write T as T half. X is what? A by 2, right? So now we will put these two value here. Okay, so it will be K T half is equal to ln A by A minus X. In place of X, we are putting A by 2. Okay, so what will happen? It will be ln A by 2. So it will be ln 2. Okay, now what we will do is, we will write it as K T half ln 2. Okay, so T half will be ln 2 by K. We can remove this ln by multiplying 2.303 and converting the ln into log 2 by K. Here I had multiplied 2.303 and converted this ln value into log value, and the K remained as it is, and this 2 also remained as it is. Now we will solve this. So it will be T half is equal to 2.303 into log, after solving this value, we will get 0.693 by K. You don't have to remember the value of log 2 or something. You just have to find it in your scientific calculators or the books or the formula books in the chemistry. Okay, so I had put the values of log 2 and multiplied it with 2.303. As a result, I had found the value 0.693 here. So T half for first order reaction is, half-life period is 0.693 by K. This is how we calculated and understand half-life period for both 0 and first order reaction.